Okay, so by the end of this video, you should have Snake working like this. I can still go off the edge, but when I eat food, I can get it working. I get a tail. So I'll show how the tail works. And there's one other thing that I've done here since the last one, which is to prevent myself from, at least trivially, going back over myself. I wish I was slightly better at this game. Get myself a reasonable tail first. Okay, so if I am now heading left or right, then I can't go back over myself. Same if I'm going up or down, I can't. If I'm going up, I can't immediately go down. So what I'm going to do now is I'm going to engineer it so I'm going up, and I'll press down. I'm now going up, and when I press down several times, nothing happens. So I can't sort of turn that 180 degrees any longer, and I'll show you how that works. So I've got the tail working here, but the legality doesn't work. I can run over myself without the game ending. So there's nothing to do with conditions that are game over. We'll do that in the next video. Let's just see how this code works. Okay, I think everything is the same here. This is code for drawing the tail, which we're going to do. So we clear everything, draw the food, draw the tail, and then draw the head. I want to draw the head last, so that when I do bash into myself, you actually see where the head is. It draws on top of the tail rather than underneath it. So I've changed the order of things, I think, a little bit there. I'll come back to exactly how that code works in just a second. What else have we got? This game over shouldn't actually be there. That occurs in a later session or whatever, later video. So let me here, get rid of that. Okay. What else? And then a couple of things about how the tail grows. And I'll explain those in just a second. So let's start down here. The only extra thing I've done here is I've defined a list called tail, and it starts off being empty, reasonably enough. Let's look at what happens every time we update. Now, Snake X, Snake Y, at the beginning of update, before I've changed the position of the head, you can think of Snake X and Snake Y as where the head was, the last place where the head was. What I do here is I essentially add the current position of the head to the tail. So the tail grows, if you like, from the sort of neck downwards on the snake. And each time I update, I actually go ahead and grow by 1 square. What I then do is I delete that extra square of growth if I haven't eaten anything. If I have eaten something, I don't delete it, and that's the mechanism whereby I grow. So I've got this tail here, and I stick the current coordinate of the head onto the tail. Then I change the position of the head. Then I check to see if I've eaten food. If I have eaten food, I replace the food, and crucially, I don't remove this coordinate that I've added to the tail. But if I if I don't eat food, then I just get rid of it. So I only grow if food has been eaten. So what I could do here to show how this works a little bit more clearly is just print the tail. and run this again. Way that the game is running, and that's my empty tail that is being drawn again and again and again, and that's why you don't see anything on the screen. And I go up, down, left, right, and as soon as I eat something, I can engineer it, you'll see that there is now a coordinate in the tail. So what's happening there is I'm adding I'm adding where the head was and removing the end of the tail, the far end of the tail, and that's what makes the tail drag along with me. And every time I eat food, I allow it to grow by 1, and you can see how the list of coordinates is growing every time I eat something. So have a quick look at that list. The list is actually a list of tuples, or a list of very specifically of pairs of numbers. So it's a list of x, y's, and let's have a look at now how those are drawn. Get rid of that. Every time I draw the screen now, I get rid of everything. I draw the food wherever it should be. It may have just been updated if I've eaten, otherwise it just sits there at the same food x and food y. And then for every pair in the tail, which I refer to as chords, I draw a square at chords 1, chords 0, chords 1. That's to say, I draw a square at 240, 220. Then I go ahead and draw one at 240, 240, and then I go ahead and draw one at 240, 260, and so on. And that draws me the entire tail. And the colour is this sort of default grey. Then I go ahead and draw the snake's head right at the front of the tail on this XY. So it's a bit weird the way that the tail grows. But insofar as it sort of grows from the neck backwards, but what happens is I add one at the front, if you like, of the tail, and delete one at the back, and add one at the front and delete one at the back, and add one at the front and delete one at the back, and that's me moving. That's the tail. That's the snake moving through space. But if I happen to eat something, I don't remove one from the back. And it's that is the growing of the snake. Okay.